Don't worry about it, it's not that difficult. Today we're going to teach you all you need to know about radical halogenation.
A radical is an atom with an unpaired electron. Therefore, they are highly reactive. Radical halogenation has 3 steps: initiation, propagation, and termination. The initiation phase is the generation of the halogen radical that will eventually add to the alkane. This is achieved by breaking the bond between the molecular halogen with 1 electron from the bond going to each atom, thus forming 2 radicals. Second phase is propagation. In this phase, the actual desired product is formed as the radical reacts with the alkane, first forming an acid and an alkane radical, which then reacts with another molecule of halogen to form the product and regenerate the halogen radical. This same radical can then react again. The termination phase is the final phase. This is where the radicals react with one another to form less reactive molecules. There are multiple possible products in this phase, including the desired product. However, a small amount of side product also appears from the reaction of the alkene radical with itself. This reaction is called radical halogenation, but not all of the halogens are ripe for this reaction, namely fluorine. It is way too reactive. Here is a real-life example of radical halogenation. First, the chlorine-chlorine bond is broken to form 2 chlorine radicals. Next, an alkane reacts with a chlorine radical, forming an alkane and hydrochloric acid, which is not pictured. The alkane radical then reacts with molecular chlorine to produce a haloalkane and regenerates the chlorine radical. The last step is termination, where any 2 radicals that were formed throughout the reaction come together to form a bond. And that is radical halogenation of alkanes. Thank you for your attention.